This is Mrs. Benke, and this is our second screencast on types of bonding, and this type of bonding is covalent bonding. Let's get started. Covalent bonding will occur between two nonmetals. Remember on your periodic table, there's that red staircase that's on the right-hand side of the periodic table. All elements to the left of this staircase are metals, and all elements to the right of this staircase are nonmetals. So this type of bond occurs only between two elements that are to the right of the staircase. The only exception is hydrogen, which is sometimes involved in covalent bonding, and it can also be used here, but it's not to the right of the staircase. What happens here is that these two atoms that are bonding are going to share their electrons until they both have 8 valence electrons. So we're not trying to get rid of all of the electrons on one and get to 8 on the other. We're trying to end up with both elements having a total of 8 valence electrons. And we're going to show how they're sharing their electrons by circling the electrons that are being shared. Let's take a look at some examples. Just like in our ionic bonding, we are going to start these problems by drawing our Lewis dot diagrams to show the number of valence electrons. So we're going to start with nitrogen, and nitrogen has 5 valence electrons. And then we have hydrogen, which has 1 valence electron. Now, what's a little different here is that hydrogen only wants to have 2 valence electrons to have a full outer shell. It doesn't need 8, it needs 2. And the only place where we can share electrons are where the electrons are single. So up here where we have a pair of electrons, no sharing can occur there. The only place on hydrogen where sharing can occur is here, and the only place on nitrogen where sharing can occur are these 3 locations where there are single electrons. So we're going to start by having hydrogen and nitrogen share those electrons. That gives hydrogen 2 valence electrons, and it gives nitrogen 1, 2, 3, 4, 5, and 6 valence electrons. Nitrogen needs more valence electrons, and the way we're going to add more valence electrons to nitrogen is to add more hydrogen. So let me add another hydrogen here, and these will be shared, and that gives me 2, 4, 6, 7 valence electrons for nitrogen. I'm still not completely done. I need to add another hydrogen here, and these are going to share. And now I know I'm finished because each hydrogen has 2 valence electrons, and nitrogen now has 2, 4, 6, and 8. What's happening is that all of these electrons that are included in the circle are being claimed by both elements. So nitrogen thinks it has these 2 electrons, and hydrogen also thinks it has these 2 electrons. This type of bond that we see here is called a single covalent bond. It's a single bond, and the reason it's a single bond is because one pair of electrons are being shared. So whenever there's one pair of shared electrons, we call it a single bond. Here in our next example, we're going to combine sulfur and oxygen. Sulfur has 6 valence electrons, and oxygen also has 6 valence electrons. So, like we said before, these electrons that are paired up, they cannot be involved in the bonding. So the only electrons that are available to be involved in bonding in sulfur are these 2, and the only ones that are available for bonding in oxygen are these 2. So what we're going to do is share a pair of electrons between the sulfur and the oxygen. My problem with that is I still have this single electron on each element that needs to be involved in sharing. So I'm going to go ahead and share those also. Now if I go back and check, sulfur has 2, 4, 5, 6, 7, 8 electrons, and oxygen has 2, 4, 5, 6, 7, and 8 electrons. So both of them are full. Another way that we can write this is in a structural formula, which is where we show our shared electrons as lines. Okay, and then we just add our extra electrons on. So our formula here is SO, And because we're sharing two pair of electrons, we call this one a double bond. Okay, so a double covalent bond is whenever two pair of electrons are being shared. All right, here in my last example, I'm combining two atoms of nitrogen. So again, we start with our Lewis dot diagram. Each nitrogen is going to have 5 valence electrons. And we remember that the only place where we can share electrons are where we have these single electrons. No sharing can occur where the electrons are doubled up. So I'm going to share all the single electrons I can find. And I'm going to go back and I'm going to count to see how many electrons each atom has. So this nitrogen has 2, 3, 4, 5, 6, 7, 8 electrons. And this nitrogen has 2, 3, 4, 5, 6, 7, and 8 electrons. When I go back to draw my structural formula, I'm going to show nitrogen sharing 3 pair of electrons with 3 lines with the other nitrogen. Again, because I'm now sharing 3 pair of electrons, this is called a triple covalent bond. A triple bond, because we're sharing 3 pair of electrons. So in covalent bonding, the 3 types of bonds that we can form are single bonds, double bonds, and triple bonds. Try these 3 practice problems on your own. Show how the electrons would be shared between 2 atoms of oxygen, between carbon and oxygen, and between carbon and hydrogen. Include the practice problems on the bottom of your notes and either submit your paper copy to Mrs. Benke or take a picture of your notes and upload them into Schoology.